Hi, hello friends. Welcome back to Max Lecture Series. In this today lesson, we are going to learn how to differentiate, how to directly identify whether the given differential equation is linear one or non-linear one. If you observe the given differential equation, dy by dx plus x times of y equal to x square. The question is whether it is linear one or non-linear one. Sir, how can we do that? So before giving the answer for that question, here I have brought few more equations. I am calling it as linear equations. Now let me tell you why these equations are called linear. After understanding this, you can automatically give the answer for this one. See, now take the equation number 1, first one. I am calling this equation is linear equation. Sir, how can we say this equation is linear? Let us see. A equation is said to be linear when the given differential equation degree is going to be 1. Degree means what, sir? See, if you observe the given differential equation, start from the highest order. Highest order means you should check in the power of d what is the highest value. In this entire differential equation, the highest power of d is 2. Here, the highest power d equal to 1. Sorry, d power 1. After that, there is no d terms. Now, what you have to do is, just to put one whole bracket for the highest order, cross check whether the degree of the highest order is 1 or not. Repeat the same procedure, then take the next order, put one whole bracket and then check whether the highest degree is 1 or not. After that, see there, here we are differentiating d square y by dx square, dy by dx. So next again you have to check in the power of y also whether we have 1 or not. If this condition is satisfied, condition number 1 is satisfied. Next what you have to cross check is, now if you observe we are differentiating y, everywhere we are differentiating y only with respect to x. So the next step is, in front of this d square y by dx square, dy by dx and y, we should not keep variable y, because we are differentiating this expression with respect to y only. So this y term should not exist in any form, y square, ln y, what I can say, cos y, sin y, any type of y should not be exist in front of this d square by dx square, dy by dx and in front of y also. If y is not exist, then second condition for linear equation also going to be satisfied. If these two things are perfectly satisfied, then you can very easily say that the given equation is said to be linear one only. Now if you observe the given equation, first what I told you, in the power of d square by dx square we have degree 1, in the power of dy by dx we have degree 1, and then in the power of y also we have degree 1. Condition number 1 is satisfied. And then I told you, in front of d square by dx square, d square y by dx square, we should not keep y. Again, y means you have to remember, it may be y, y square, y cube, y power 4 or ln y, e power y, cos y. Y should not be exist in any form in front of this differential order. That is the second condition. So if your given function is satisfied in these two, then you can directly say that the given equation is said to be linear one. Remember one more thing, here at last in this differential equation, suppose this y is existing alone. Whenever you are observing that this y also given and it is existing y alone. Now you should check whether this y is existing alone or it is multiplied like this, ln y, cos y, sin y, e power y. If it is given like this, then that is also going to be non-linear only. Linear equation means y should exist alone and in the power of y degree must be 1. That is the condition for linear equation. Now let us take the second one. If you observe, see there, we are starting from, what is the highest order here? Highest order is d power 1. Close the bracket and observe whether the power is 1 or not. Here the power is 1 only. I will be bringing you few more examples, later you can understand. Here the power is 1 only. After that, see there, again we are differentiating y with respect to x. So again check in the next term, y is existing, check whether the power of y is 1 or not. Yes. And next we have to check whether, whenever we are observing y alone, we have to cross check whether y is existing alone or it is existing in the form of ln y, e power y, cos y, like in this format. If it is not existing in this format, just cross check the order, sorry, degree. Yes, degree is 1 and other conditions also satisfied. This equation also going to be linear. Let us take the next one. See there, here also if you observe, one more thing, in the previous equation if you observe, see there, we are differentiating y with respect to x. So what I told you, the variable is y, we are differentiating y only. So in front of this differential equation, y should not exist in any form. So it is not existing. So that condition also satisfied for this. Now take the third one. Check this one. What is the highest degree of this differential equation? 1. After that, again dy by dx is given. What is the highest degree? Degree is 1 only. So in both cases it is 1 only. Next, we are differentiating y with respect to x once again. So if we are differentiating the function with respect to y, then again we have to check in all differential equation terms, y should not exist in any form. Is there any y? No, we have only x, we are not having y. So this is also going to be linear. Did you understand now? Now go back to the given example. What it is given? Dy by dx plus x into y equal to x power 2. What will be the answer? Now tell me whether it is linear or not. First cross check whether in the power we are having degree equal to 1 or not. Yes, it is 1. Since we are doing the differentiation, we are differentiating y with respect to x. So in this case, y should not exist in any form. So in this given equation, y is not existing. See, don't talk about any other variable. Other variable means here you can keep x or any other constant 10, 5, 10, whatever. You can keep any variables. But you should not keep this variable y. Just keep your attention with only the differentiation variable. Next, again cross check. Whenever I am saying that if y is existing alone, just check the degree and check whether the y is existing alone in the sense whether it is in the form of ln y, cos y, e power y, sin y, or it is simply existing y alone. If it is simply existing y alone, then there will be no issues. You can simply give the answer that the given equation is going to be linear only, sir. Now see there, I told you, within 3 seconds, even 3 seconds not required to give the answer for this type of question. Now let us take, see what I told you, you have to start from highest order. Highest order we can check. Order means in the power of d you can observe the order. Highest order is 3. Now check in the whole power whether we are having 1 or not. If 1 is not existing, then from there itself you can write that given equation is said to be non-linear. Because what I told you, in case of a linear equation, degree of all differential term is going to be what? Differentiation term should be 1. So here, if in this case, if you observe here degree is 2. Second, if you observe, see there, dy by dx in the whole power, degree is 3. So already one condition is invalid. So this given function is said to be non-linear. Let us take one more example here. See there. If you observe, what is the highest order here? Highest order we can observe in the power of d. So highest order is d power 2, sir. Now if you observe the whole degree, it is 1 only. If it is not given any values, see in the previous case it is given that in the power we have 2. Here they have not given any value. By default, if there will be no any value, then we can say this is 1 only. But if you observe the second case, dy by dx in the power we have degree given as 2. So what is the given? The given equation is said to be non-linear. Sir, this is non-linear differential equation. I hope now you all understood how to identify the linear and non-linear equations. In the next lecture, I will be bringing few more example. In order to understand it clearly, one more time watch the lecture. This is all for this lecture. In the next lecture, we will be solving few more questions. Thank you all.